Hey everyone, and welcome to this explainer. Today we're taking a humble, educational look at the design philosophy behind a very specific and, honestly, a highly opinionated domain-specific language. Specifically, we're breaking down Post 24 of the Merg-E language specification series. Now, if you've been following the development of this Web 3.0 DSL for the Inundo stack, you already know it's a language built from the ground up, with strict least authority principles for writing bots and Layer 2 nodes. But today, we aren't just looking at the syntax. We're actually looking at the multifaceted meaning behind the language's name itself to really understand the core architecture it relies on.
Okay, let's dive into this. First, we'll look at the name behind the code. Second, merging paradigms and pet peeves. Third, the Yggdrasil graph model. Fourth, the merge import contract. And finally, redefining code dependencies.
Section 1. The name behind the code.
You know, when you're designing a language completely from scratch, the name you choose usually reflects your foundational design philosophy. And the creator of Merg-E notes that the language actually earns its title from 4 distinct functional pillars. First up, it's literally a merge of acquired programming pet peeves. Second, it's a practical blend, or merge, of distinct programming paradigms. Third, it references the Git-like merges happening continuously within the Yggdrasil graph model's memory management. And fourth, merge is the actual explicit command used for imports in the code itself.
To truly grasp this language, we really have to appreciate the historical weight of its design choices. As the creator explicitly states in the specification, Merg-E is a direct response to, quote, many of the pet peeves that I acquired about programming languages in the 40 years since I first started seriously dabbling with BASIC and Forth. Think about that. This isn't some academic exercise created in a vacuum. It is a highly practical tool forged from 4 decades of real-world frustrations and lessons learned across dozens of different languages.
Section 2. Merging paradigms and pet peeves. Let's explore how these frustrations actively shaped the compiler.
Now, what's really interesting here is how Merg-E tackles one of the creator's biggest pet peeves, numeric types. In a lot of modern languages, arbitrary-sized integers are used to prevent overflow. Sounds great, right? But it actually solves one problem by creating a massive new one. Simply adding 1 to a variable could suddenly trigger a runtime out-of-memory error. In systems and cryptographic programming, allocating storage on demand for numbers absolutely destroys both time and memory predictability. So what's Merg-E's solution? It enforces a strict use of fixed-sized integers for all powers of 2. This ensures exact memory predictability and allows large-field arithmetic to be handled natively and, most importantly, safely.
Moving beyond just pet peeves, the language is also a merge of paradigms. Listen, Merg-E does not try to be some academically pure implementation of any single computer science theory. Instead, it's a really pragmatic blend of 4 concepts: object capabilities for least authority security, the actor model for persistent state execution, parallel functions for ephemeral schedule tasks, and key aspects of data flow languages. The creator is totally upfront about this. This merge is filled with smart, small compromises to fit within limited development time resources and to make absolutely sure the language operates smoothly across multiple planned runtimes.
Section 3. The Yggdrasil graph model and memory management.
So in Merg-E, ambient authority and data are managed through a directional acyclic graph, a DAG. Think of it kind of like a one-way flowchart, starting from a root scope. To provide stable snapshotability, even when the system is processing a bunch of tasks in parallel, the Yggdrasil scheduling and memory model executes a Git-like merge. When data mutates or the DAG structure updates, those changes are cleanly merged right back into the Yggdrasil branches. So the concept of merging isn't just an idea, it's actively running under the hood of the language's state management at all times.
Section 4. The merge import contract.
Okay, here is where the word merge transitions from a background design philosophy directly into written syntax. Because Merg-E is completely closure-oriented, programs could really easily devolve into massive, deep nesting with just terrible code duplication. To solve this, the language introduces the merge expression. Now, it's absolutely crucial to understand that this is not a standard import statement like you'd find in Python or JavaScript. No way. Merge is a strict contract. It acts as a dual-purpose tool that brings in external code while also allowing for explicit dependency injection and surgical authority control over what that imported code is actually allowed to do.
Section 5. Redefining code dependencies.
And this brilliantly illustrates the stark contrast between traditional programming models and Merg-E. Let's look at how this plays out in practice. Traditional imports, well, they simply pull external code into a file, often polluting the global scope and implicitly trusting the imported module with whatever ambient authority the running program happens to have.
Merg-E's merge construct flips this entirely on its head. The scope remains surgically localized to the specific closure, and dependencies are explicitly contracted. That means the imported module only gets the exact authority injected into it by the merge expression, nothing else.
Now, to make this strict dependency injection usable without driving developers crazy, merge provides a specific syntactic convenience. When you use the merge construct to bring in a function from a module file, you have to pass it the mutables and inerts it needs to run. However, you don't need to explicitly express the types of those dependencies on the merge side of your code. Why? Because the captured elements, the mutables and inerts themselves, already inherently contain their type information. It's a clever way to keep the strict contract clean and readable, for sure, without sacrificing any type safety.
Ultimately, the design of the merge construct, and really the entire Merg-E language, isn't about making coding more complicated. It's about making security an inescapable part of the architecture. By utilizing strict dependency injection, the language directly intertwines its daily written syntax with least authority security. When you are building Web 3.0 Layer 2 nodes, bots, and backends, this explicit control over authority is simply a baseline structural requirement for the code to function safely. Thanks for joining this explainer.